Okay, so hello and welcome to this module. If as you remember in this short term course module, what we have actually 3 module in this very short course on life cycle assessment, and within that 3 module we have already covered, we have the videos on module 1, module 2 and module 3 and on different aspects. So, in module 2 we have 2 videos. So, we will get started for the first one in terms of trying to introduce this GREET model. As you may be aware of this GREET model, which is developed by the Argonne National Laboratory, and we want to make it very clear that as part of this project is not associated with the GREET model, though we are really grateful to the Argonne National Lab for support at points throughout the project. So, we really thanks them for helping us as part of this particular project. So, let us get started. So, in terms of again the GREET model, this is essentially in that application of life cycle analysis. So, we are trying to use LCA in this particular transport sector. So, that is the whole the big picture simple way, if I need to explain, that is what we are that is what the GREET model is trying to do. So, why LCA? Because LCA as mentioned as explained in the previous module, you may have gone through those videos as well, is a major step to holistically evaluate sustainability of technologies and policies. It's trying to look at the complete supply chain. It's not only try to make sure that we are not shifting the burden from one stage to another. So, have a more holistic approach, and LCA thinking has actually helped changes in corporate and consumer behavior. So, what is the in terms of the recent trends of LCA application, they are looking at in terms of especially from the US perspective and also from European Union perspective, and then now in many developing countries these things are also coming in. We are trying to use LCA in terms of domestic regulations and programs, in terms of proposed rules for security exchange commissions to require reporting of emissions of 3 scopes, like a scope 1, scope 2, scope 3 for companies' climate risk assessment, to look at like if you want to go for incentive for clean hydrogen, sustainable aviation fuel or clean fuels, are they really clean, how much they are clean. So, they are being assessed based on LCA greenhouse gas results. There was in fact in the bipartisan infrastructure bill required LCA based GHG for projects under different hubs. So, this is what was happening in US in recent times. International activities is also going to Canadian Clean Fuel Standard, Brazilian program, European Union, international marine organizations looking at potential low GHG fuel standards. So, all those, as you can see, that LCA is being used as a tool not only in US, but in globally and also in Europe, in terms of trying to come up with more holistic approach to when we are trying to move towards a less carbon intensive infrastructure projects or economy in general, we can say. So, as we are talking about decarbonization of the India's transport sector, we are looking at just a second. So, what LCA approach, and so when we do this LCA, there are LCA approach and related system boundaries like process based LCA, we talked about that in the previous module as well. That is sometimes also called as attributional LCA, where you are looking at the entire supply chain of products and technologies. So, life cycle based approach, mass and energy balance there is a key, looking at the mass and energy, how they are being used. Then we also look at the 3 scopes, scope 1, scope 2 and scope 3. Scope 1 is whatever is happening, say I am running any particular industrial setup, whatever is happening within my industry is my scope 1, and the scope 2 is that where I am getting my energy and other things from there, that becomes a scope 2. A scope 3 kind of takes the entire supply chain. So, that is one approach. Other one is economic input output approach, where you are complementary to process based LCA. So, you have to look at the economic linkages among activities. There are also people talk about consequential analysis, sometimes so called consequential LCA, global economy wide effort for the regulations program, those are there. Co-products, there are also co-products in LCA, like in terms of related to approach 1 and 2, we are looking at process based or emissions of the 3 scopes. displacement, system boundary expansion, mass allocation, energy allocation. So, there are different methodologies for LCA which is out there, and so when you are working on in terms of any particular LCA exercise, we need to make sure that we understand what approach has been taken there and what approach needs to be taken based on either regulatory requirement or based on what is the end goal. If you remember LCA, again the ISO methodology that we talked about earlier, we have the 4 basic steps: goal and scope, inventory analysis, impact assessment, and then interpretation. So, for all these particular LCA, especially for the comparative purpose, in terms of functional unit, we look at megajoule, kilogram of transport, miles of transport, ton miles of transport, and etc. So, we are trying to comparing products providing identical or similar services to consumer and society, which we kind of talked about, that you need to give similar level playing field. So, per unit of inputs are also looked at. So, per like how much BBL of oil or per ton of biomass, best use of limited resources, those things we also kind of see, we get into those. So, LCA is a data intensive exercise. You need lots of background data, foreground data, primary versus secondary data. Primary data is data from the facility operator, secondary is what we got from simulations, literature data, approximation. There are also confusing terminologies are there, LCA data versus LCA results. So, life cycle inventory data, which is the data for LCA, or energy mass balance, embodied energy, emissions of input energy. So, huge amount of data is required, and sometimes they also gets quite confusing of them as well. So, in terms of data quality is also important, quality rating, technology readiness level, TRL level of different data availability and data quality, those are important. So, when we look at this LCA in terms of execution and results reliability, we try to look at what is the precision, like perceived precision is the major problem. So, point estimation modeling, that is, so user of LCA usually want point estimates. So, in terms of how much emissions will be coming out at this point versus that point, which kind of gets a bit confusing. So, there are stochastic methods in LCA in approach 1 and 2, where probability distribution functions are used, which is and then objective versus subjective PDFs are done there as well. Scenario analysis could be done, sensitivity analysis. So, these are all there in our GREET model. So, GREET model, it covers, another model covers fuels, materials, and technology. So, we have the fuel cycle plus the vehicle cycle, which is the cradle to grave model. So, fuel production cycle, then the vehicle operation, because if you are looking at entire, if you think about from beginning to the end, the fuel is being made, vehicle is being made. So, vehicle, so we have the 2 component here, as you can see in the top over here. You have the vehicle. Let me grab my pointer, which will make it look a bit better. Laser pointer. So, I am talking about here on this circle, we have the fuel production and the vehicle operation. On the right side, we have the vehicle manufacturing and the vehicle end of life. So, that is called vehicle cycle, and here we have wheel to wheels fuel cycle, because we are talking about the fuel. And we try to capture because both are important. When we are talking about the transport infrastructure, both are important. So, both we need to look at. So, in terms of the GREET model, what is it's called as, the short form is GREET, the greenhouse gases, regulated emissions and energy use in technologies. So, that is what we are looking at. So, examines the life cycle impacts, simulating the energy use and emission output for the vehicle and fuel combination. So, what vehicle and fuel, like whether diesel, petrol, other vehicle types, the renewable energy or alternative energy. In this the project that we have worked on, we are looking at what are the different fuel types in terms of biofuel and others which could be used, what is its carbon footprint. So, we looked at emissions output for vehicles and fuel combinations covering road, air, rail and maritime transportation. So, it is available at the GREET. They have a website, greet.es.anl.gov. Again, as I said in the beginning of this video, this project is not we are not part of the GREET, but we are really thankful to GREET for helping us and providing us all these information that we are sharing with you. In fact, all the presentations that I am sharing with you is actually the information has come from the GREET model itself. So, for example, here if you look at like there are two examples have been given where brine recovery to brine concentration, truck transport, then you have lithium carbonate and lithium hydroxide production, trunk transport for that, ocean transport, land transport, and then you look at all the cathodes product and battery production. So entire battery production for the lithium battery has been, what are the different steps that goes, everything needs to be captured as part of the life cycle analysis. So DOE has the main, DOE, Department of Energy, is the main sponsor for the GREAT, and they have DOE has like a vehicle technology office, hydrogen fuel cell, bioenergy and all that, and then we have there are different offices in terms of ARPA-E, then fossil fuel, nuclear energy. Then there are other federal agencies of DOT is also involved, USDA is also involved, numerous state association and corporate sponsors in energy and automotive materials and other sectors are involved here too. So what the GREAT LCA, what it does, what is its objective? It builds LCA modeling capacity. It's a consistent LCA platform with reliable, widely accepted methods and protocol. So they address emerging LCA issues, they access to data sources and conduct detailed analysis, they document source of data, modeling and analysis approach and results, maintain openness and transparency of LCA by making GREAT and its documentation publicly available. As I showed you that website, it's a primary, most of the information that is being presented right now is actually available in that website. So you can primarily process based LCA approach, the so called attributional LCA, and some consequential effects are also incorporated. So it's a variety of data source. They look at the baseline technology data, field operation data, simulation and with models data, collaboration with other organization industries. So all those data they collect. And these slides, as you know, is actually available on the same website where you are watching video from. So you can always go back and look at some of the details which I'm kind of skipping as part of the website, because there is no point kind of reading them from this slide itself. So GREAT, what it does, it's in terms of sustainability metrics in GREAT, they include energy use, criteria pollutants, greenhouse gases and water consumption. So here in terms of energy, you can see the total energy, fossil, renewable, both. Fossil, whether it's a petroleum, natural gas, coal, renewable, you could have biomass based, you could have nuclear, hydro, wind power, solar power, then all the emissions coming out, VOCs, carbon monoxide, NOx, PM10, estimated separately for total and urban, a subset of total emissions. Then greenhouse gases, CO2, methane, N2O, black carbon, and all those CO2 equivalent of the 5 combined with their global warming potential. Then we also look at the water, addressing water supply and demand, energy water nexus, results used in like AWRE US for water stress impact as well. So there are 50,000 registered GREAT users globally. So it's not GREAT is being used by a variety of as you can see from the logos all around, it's the research organizations, it's the companies, even the US EPA and other government authorities. So it's many people, it's a well received, it's a well received where people, and then you can see that nearly 30% is users of GREAT.net only, and both GREAT Excel, and then users of both GREAT Excel as well as the .net, like the web platform, is around 12%, and there are 58% who uses only the Excel, and then they probably use their own data and get done as well. And in terms of those, there are North American institutions, nearly 64% of North American institutions, academic institutions, North America uses is more in North America than in Asia, than in Europe. North America, then Europe, then Asia, and then others. And others we have Middle East, South America, and all that. In terms of where it is being used, academia is 50%. Of course, it's most in academia, research institutions, private consulting, industry, government agencies. So after academia, it is the industry, which is around 20%, which is using this model. So they cover all transport subsectors: road, rail, air, as well as the marine environment. So all those things are covered. Covers many groups of energy like petroleum, natural gas, hydrogen, renewable energy system, electrofuels, electric systems, all these are getting covered there. So many groups of energy system, they looked at the petroleum sector in terms petroleum, gasoline, diesel, jet fuel, all. Then we have natural gas system. As you can see, we have the natural gas system, CNG, LNG, alternative fuels, hydrogen economy, electric system, renewable energy fuels, renewable hydrogen, electrofuels, CO2 sources. So everything they try to cover many groups of energy systems as part of their model. So they have their data collected from there. And they also include Cree propulsion technologies for light duty and heavy duty vehicles in terms of when we are talking about wheels to wheel in terms of hybrid electric vehicle, or you're talking about fuel cell vehicles, battery powered vehicles, plug-in hybrid, spark ignition, direct injection engine vehicles. So they are looking at Cree propulsion. They do include Cree propulsion technology. So it includes a suite of models and tools. So if you go on their website, which is a link was provided earlier on a slide, you can look at the fuel cycle, which is the GREET 1, where for like a well to wheel model of vehicle technologies and transport fuel. Then GREET 2, which is the vehicle manufacturing cycle as well. There are in-depth application for LCA of batteries and EVs, LCA of hydrogen production pathways. There are derivatives as well. They have the aviation modules, they have marine modules, rail, how to build the building of LCA module, then wheel to like well to wheel calculators. All those things are there, and then there are some the variations of GREET as well, like China GREET is there, California GREET is there. There is a most likely as far as an output of this project, and sometimes from down the line we'll try to have a Indian GREET there as well. So this is their kind of website, where it's you can go to that particular website. This is how their website looks like, and then you can look at the details from the particular website there as well. So it's an adaptation of, as I said, California GREET is adaptation of Argonne GREET model. Oregon is also adapting that, US EPA, National Highway, Canadian Clean Fuel Standards. They also, so there is a it's a good resource, globally available resource. So that's really nice. That we all can use this resource. So that's the reason why we included this particular module as part of this particular project, so that you can look at and then try to use it and adapt this one based on your requirement. So GREET 1, there are some updates where hydrogen production pathway has been expanded, CO2 utilization in carbon accounting, CO2 capture, offshore macroalgae production, looking at marine fuel production pathways, biodiesel, renewable diesel, post-use plastic pyrolysis, expanded waste to polylactic acid and plastic modeling. So that is also there. So those are all included there. GREET 2, which is updated infrastructure LCA for nuclear power plants, LCA for electrolyzers, then updated and expanded battery LCA module is also there, inventory data for aluminum production, LCA for critical materials, end of life credit approach for vehicle recycling. So all those things for steel and aluminum. And background data, they are using a global warming potential of AR6, US electricity generation. So since this is based out of US, most of the data is US specific. So when we are working in other countries, so we have to try to take this model and adapt it to our countries as well. LCA results are subject to variations. LCA system boundary depends on its scope. Let's say attributional consequential LCA, they differ, several questions, completely different boundaries. Co-product methods are subjective. Then you have data which we talked about earlier, temporal variation, spatial variation, uncertainty of the data, limitations of competitive results. Like so, all those things is also there, like a different TRL levels and all. So all these is definitely there as part of our GREET model as well, but we need to kind of take care of that when we like any other LCA model. So we have to kind of make proper like assumptions, proper data selection, and making sure the data quality is there. So that was kind of an overview of the GREET model. You can always go to their website and learn more, because that it's a several years of a hard work which has gone into making that model, and it's a useful tool for use for anywhere in the world. So thank you for this, and then we will go to the next video where we talk more about how the GREET could be applied in Indian context. So thank you.